This is the first video of a series on straight line. In this video we're going to look at gradient. To give a measure to gradient, we put how much a line rises vertically compared to how far it has moved horizontally. So for example, in this line between the 2 points A and B, for moving one box horizontally, the line has risen 2 boxes vertically. So if we put the vertical 2 over the horizontal 1, we get the gradient to be 2. M, lowercase m, represents the gradient. So this reads as gradient is 2. If the line is steeper, so for example here, it's now rising 3 boxes for moving one box horizontally. The gradient is 3. The steeper the line, the higher the number is for the gradient. In this case, it rises 3 boxes for moving 2 boxes horizontally. So that's vertical 3 over horizontal 2. So we write it as a fraction. If it's top heavy, that's an improper fraction. We'll leave it like that. It can be written as 1.5 or 1.5, but we tend to leave it as a fraction, even if it's top heavy. If it's going to give you a fraction, it will simplify. 4 over 2 in this case simplifies down to 2, 4 divided by 2. Then we fully simplify it. In this case, 6 over 2, that's the same as 3. So it doesn't matter whether it comes from 3 over 1 or 6 over 2 or anything similar. As long as that ratio is the same, vertical over horizontal, the line will have the same gradient, the same steepness to it. At 45 degrees, a 45-degree angle to the horizontal, the gradient is 1. So here it's 3 over 3, which is 1. Beneath 45 degrees, so less than 45 degrees, your gradient will be less than 1. So here it's a half, 2 over 4. Here it's a quarter, 1 over 4. So any fraction less than 1 is less than 45-degree angle to the horizontal. When it's over 1, like here it's 4 over 3, then it's greater than a 45-degree angle to the horizontal. For a horizontal line, the vertical component is 0, so here it's 0 divided by 4. That results in a gradient 0, so for a horizontal line it's gradient 0. For a vertical line, the horizontal component is 0, so it's a division by 0. That's not possible. You cannot divide by 0. So that's undefined. There's no number for 4 divided by 0. Sometimes that's said to be infinite gradient. The next thing is the horizontal component here is positive 1. If it was going to the left here, the horizontal component's negative 1. So it's 2 over negative 1. Negative 2 is a gradient. That's a line that goes downwards. So if a line is going down here to the right, it's a negative gradient. If a line is going up the way, it's a positive gradient. So that's positive 2, 2 over 1. And this one is negative 2, 2 over negative 1. So there would be, for example, negative 2/3. It's going down to the right, 2 over negative 3, as opposed to over here, that's positive 2/3. So positive gradient going up the way to the right, negative gradient going down the way to the right. So if a line goes up, the gradient is positive. If it goes down, it's negative. If the line is horizontal, the gradient is 0. And if the line is vertical, the gradient is undefined or infinite. Now the next thing is to look at coordinates. So if I put the axes on here, and there's the coordinates up here, A 0, 4, B's negative 3, 2. The components come from the difference in the y coordinates, 4 minus 2, top line 2, and 0 minus negative 3, bottom line 3. So it's the difference in the x and the y coordinates that determine the gradient of the line, not the actual coordinates themselves, because these points can be shifted about. So the points are changing their coordinates, but the difference in the y coordinates and the difference in the x coordinates don't change. So these points A and B are in different places, different coordinates, but as long as the difference in the y coordinates and the difference in the x coordinates stays the same, then they've got the same gradient. So the difference in the y coordinates here is 2, there it's 3 minus 1, and the difference in the x coordinates 3, 4 minus 1. So I'm doing A minus B, top minus bottom. A minus B is 3 minus 1, A minus B is 4 minus 1. 3 minus 1 in the top, 4 minus 1 in the bottom. So that's coordinates. It's the difference in the y coordinates gives you a vertical component, and the difference in the x coordinates gives you a horizontal component. Now that's the main parts of gradient. To take some examples here. This is a summary. The gradient M is the vertical over the horizontal. So in this first one, it's 6 boxes on the vertical, 3 in the horizontal. So that's moving between 2 points on the line. M for gradient, lowercase, M is 6 over 3, 6 divided by 3 is 2, that's gradient 2. This one, between 2 points on the line, a vertical rise of 3 for a horizontal distance of 6, gradient's 3 over 6, that simplifies to half. 3/6 is 1/2. In this case, it's sloping down, which should be a negative gradient. For 3 in the vertical, it's negative 6 on the horizontal. 3 over negative 6 is the gradient, that's negative 1/2. It's a positive 3 divided by a negative 6, gives you a negative answer. And this one here, for a vertical rise of 6, it's negative 3 on the horizontal. 6 over negative 3, 6 divided by 3 is 2, but a positive divided by a negative will give you a negative answer. So up the way to the right, positive, down the way to the right, negative. So a line going up is positive, going down is negative. Horizontal gradient 0, vertical gradient undefined. That's it summarised here. And when we looked at coordinates, the vertical rise was the difference in the y coordinates. This is the y coordinate of the second point minus the y coordinate of the first point. This is the x coordinate of the second point minus the x coordinate of the first point. So here, it's a y coordinate of B minus a y coordinate of A. And here, the x coordinate of B minus the x coordinate of A. So it's B minus A for the y coordinates and B minus A for the x coordinates. So this reads gradient, M is gradient of line AB is given as y2 minus y1 over x2 minus x1. The y coordinate difference over the x coordinate difference. When you use the formula here, you've got to make sure the y is on the top and the x is on the bottom. It's the vertical on the top and the horizontal on the bottom. And remember, it doesn't matter what the coordinates of A and B actually are, it's the difference in the y coordinates and the difference in the x coordinates that matter. So that could be placed anywhere. The gradient of the line AB doesn't change wherever points A and B are placed in the coordinate plane. It's always simply the x difference and the y difference that determines the gradient. So the slope of the line is a y difference over the x difference. So, as an example, here's the line PQ. To get from P to Q, vertically I must go from y coordinate 3 to y coordinate 9. That's a difference of 6. I must rise 6. For the x-coordinates, I must go from x-coordinate being -2 to x-coordinate being 1. That's a difference of 3. So the vertical rise was 6, the difference in the y-coordinates, and the horizontal distance was 3, the difference in the x-coordinates. That's all this formula is expressing, difference in y-coordinates over difference in x-coordinates. So if I do q minus p, the top line's 9 minus 3, the bottom line's 1 minus -2. Here it is. Y difference over x difference. 1 minus -2 is the same as 1 plus 2, which is 3. So we get 6 over 3, the gradient's 2. If I put the grid there, we'll be able to see vertically between these 2 points, vertically that's 6 boxes, and horizontally between these 2 points it's 3 boxes. So it was 6 in the vertical, 3 in the horizontal, there's the 6, there's the 3. So that's the gradient of PQ, M for gradient of line PQ. Here I should expect a negative gradient. This line's going down the way to the right, so it's a negative gradient I should expect, but that will come from the difference in y coordinates over the difference in the x coordinates. If I look at the y coordinates, it's y coordinate 2 here, and y coordinate -1. From 2 to -1 is a difference of 3, and the x coordinates is from -9 to -3, that's a difference of 6. Now 2 subtract -1 in the top is +3. -9 subtract -3 is -9 plus 3, which is -6. So by using the coordinates, it takes care of the fact that actually horizontally it's -6, not +6. So there it is, vertically 3, horizontally -6. 3/6 is a half, but this is a positive over a negative, so it's a negative answer. That's gradient -1/2. If you look at the boxes, there's the 3 boxes vertically, and there's the -6 horizontally. Using the gradient formula here, we don't need to know about the grid. We can simply use the coordinates. 2 minus -1, 3, -9 minus -3, -6. That's doing top minus bottom. The top point is S, the bottom point is R. So if you write the coordinates one below the other, you can simply do top minus bottom. 9 minus 3, 1 minus -2. So if you look at this 9 minus 3 and 1 minus -2, here it is here. If that had been subtracted the other way around, 3 minus 9 and -2 minus 1, that's the bottom part here, P, this is P minus Q, 3 minus 9 in the top, -2 minus 1 in the bottom, that simply becomes -6 over -3, which is +2, you get the same answer. So this one is using Q minus P in the top and Q minus P in the bottom. This one uses P minus Q in the top and P minus Q in the bottom. You get the same answer as long as you keep it the same way around. If it's Q minus P in the top, keep it as Q minus P in the bottom. If it's P minus Q in the top, keep it as P minus Q in the bottom. So if we want the gradient here of BT, top minus bottom, 10 minus 4, bottom 3 minus -1. There it is. 10 minus 4 is 6, 3 minus -1 is 3 plus 1, which is 4. That simplifies, top bottom both divide by 2, simplifies to 3 over 2. So leaving it as 3 over 2 rather than 1.5 or 1.5. And this one, top minus bottom is 4, subtract -2, which is 6. -5, subtract -1, which is -4. So that's C minus R, top here minus bottom, 4 minus -2. C minus R, top minus bottom, -5 minus -1. 6 over 4 cancels to 3 over 2, but it's a positive over a negative, so you get a negative answer. It's a negative gradient. So up the way is a positive gradient, down the way is a negative gradient. But the coordinates should sort that out anyway. So if you click the link in the description, there's access to a worksheet which practices this. It just gives you a whole series of lines with points on them, and you have to calculate the gradient. We'll have the answers with it. And here it is here. So that's a worksheet. It has the answers. Also using a link in the description is a set of notes covering all the videos in straight line. This first page here is a gradient that we just went through. Shows the use of the gradient formula. And then it goes into the straight line work. The next video is on the straight line using the form y equals mx plus c. Hope you found this video useful. Thank you.